Hey guys, my name is Trevor Sullivan and welcome back to my video channel. Thank you so much for joining me for another video in our Rust programming tutorial series. Now, the topic for this particular video is going to be some data parsing using the CSV syntax. Previously in my Rust programming playlist, I actually covered how to use the serde library in order to parse JSON data, but this time we're going to be taking a look at CSV instead. Now, we used serde with JSON previously, but this time we're actually going to look at some of the core capabilities of parsing CSVs without using serde, but the CSV package or crate on crates.io also does support integration with serde as an optional feature. So if you want to use the serde route and use the standard deserialization capability into a data structure, you're more than welcome to do that. But if you just want to read a CSV file as what it is, which is basically just a bunch of columns and rows, then you can do that without having to include the serde package as well. So if you just want to use CSV as a dependency in your application without including serde, you're more than welcome to do that. And we'll take a look at both different approaches in order to parse our CSV data here. Now, if you want to grab some sample data up front when you're working through the sample, feel free to. I'm just going to go ahead and create a really simple CSV file for this particular demo, just so that we can see the process of creating and tweaking the CSV file format and just kind of customizing how exactly we read it. Now, they do have really good documentation in the CSV crate, so check out the tutorial module right over here, as well as the cookbook module right here that gives you kind of a task-oriented approach to using the CSV crate here. But it's actually a really simple package, so once you've run through a couple of iterations of utilizing the CSV package, everything should be pretty familiar to you. Now, when you're reading records from a CSV file, typically you're probably going to read those as UTF-8 string values. However, there could be some situations where certain byte sequences are not interpretable as UTF-8 characters, and you need to just read the raw bytes of data from the CSV file. So you have two different mechanisms to interpret the data from a CSV. We're going to be mainly looking at string records just because a lot of CSV files are going to have string related data or data that can be at least represented as a string and then perhaps coerced into a different primitive data type. But you do also have the option to interpret those CSV records as just a raw stream of bytes as well. Now, you can read CSV data from a variety of data sources. The way that the CSV crate has implemented reading data is actually really intuitive. So if we take a look at this reader data structure that's directly exported from the root to the CSV crate, you'll see that it implements a function here that allows you to read the individual records. And this is actually created from a builder, but when you use this function here called from reader or from path. The from path is kind of a helper that allows you to read from a file on the local file system. But if you take a look at how to read from a reader here, it actually allows you to read from any type that implements the reader or read trait from the standard IO interface. So this is a really convenient way to read data. It could be from a stream of bytes. It could be from a file handle. It could be from all sorts of different data sources. So this gives you a lot of flexibility as far as where the actual CSV data is coming from. Now, there's a couple of different ways to actually create the reader. You can just go out to the reader here and say, create a reader from a particular path. You can specify the file system path that you want to read from, and then you can immediately start to just iterate over the different records by using the records function here, which returns an iterator across all of the individual records in the CSV file. And then within each of those, you can go ahead and just grab the individual fields from those records by calling the get function. So if we take a look at the record type over here, let's go down to structs and then go to string records. And there's a get function here that we can use to index into the different columns of each row. So if your CSV has maybe 5 rows, or 5 columns, not rows, then you can reference those columns from 0 through 4 to grab the different values. If you decide to use the serde integration, though, you can actually deserialize the individual rows to a custom user-defined data structure. I have a separate video in my Rust playlist that covers how to define structs and struct methods and things of that nature. Also, if you want to learn more about serde specifically, you can go back to my video on JSON. So you can use serde to deserialize JSON objects into well-defined Rust data structures as well. But this time we're going to be doing the same thing with CSV. But if you don't decide to go to the serde route, you can always use this get function here to get a specific index of a column from a particular row in your CSV file. There's also a bunch of other kind of helper functions in here as well, like getting the length of the record. You can trim, truncate, get a particular position, things like that. So feel free to take a look at those, but we're just going to look at the essentials, which is basically iterating over records, deserializing into a data structure, getting individual columns from a particular record. And there's also some customization options that we have on the reader here. So one way is to just use the reader here and do from path, and that'll give you a reader object that you can read records from. But if you need to do any kind of more advanced customization on the CSV parser, then there's another data type you're going to want to look at, or a structure, I should say, and that's called the ReaderBuilder. And the ReaderBuilder, basically, before you get a reference to a specific reader, this ReaderBuilder allows you to call a bunch of helper functions that allow you to customize the mechanism that the reader uses to parse the file. For example, we've got things like the double quote option here. So if we have double quotes around the individual field values in our CSV file, then we can specify that there are double quotes. I think by default it is enabled, but it can be disabled as well. And then we also have things like setting a custom delimiter here. As you probably know, every CSV file can look a little bit different. Even though the CSV suffix stands for comma-separated values, you might have a tab character that is used as the separator or delimiter. You might also have something like the pipe character, the vertical pipe character that's used as a delimiter. And so this delimiter function on the ReaderBuilder allows us to configure a custom unsigned 8-bit integer that represents an individual character that's going to be interpreted as the field delimiter for each of the rows in your CSV file. We also have the ability to specify a comment value as well. So this is going to be the character that begins the record. So if maybe you have like a individual dash at the beginning of a record, that can be used to ignore a particular row because that would be considered a comment to the parser rather than being an actual data row. So you can customize which kind of character you want to use for that as well. There's also the ability to specify the custom quote character. So obviously most common CSV files are going to probably use a double quote character to indicate the delimiters around the individual field values, but you can also override that by using the quote function here. So anytime that you need to kind of customize the behavior of the parser, you'll want to go into the ReaderBuilder struct and then use that builder with the helper functions to chain the configuration files or configuration options together before you actually construct the reader itself. Once you've customized the ReaderBuilder, though, you can once again just call from path or from reader on the ReaderBuilder type here, and that will ultimately give you a reference to a reader that you can use to read the records from the CSV using the records function. All right, so we're going to go ahead and take a look at how to implement this. Also, I did want to just really quickly point out that when it comes to the reader here, when we take a look at the records, I think it's the record, let's see, I think it's the reader type here. So we have this deserialize function that we use in order to deserialize into a custom data structure. This is kind of the implementation of the serde package. And if we take a look at this trait boundary here on the generic type D that's being passed into the deserialize function here, the deserialize owned trait, that's actually coming from the serde package. It's probably a little bit small on your screen just because it's a tooltip in Firefox here. But if I hover over that, it's actually a reference to the serde de module, and then deserialize owned is the actual name of the trait under that module. So once that's implemented, this allows the deserialize function in the CSV crate to actually call into the serde functionality and deserialize into a custom data structure. And again, all this kind of stuff is covered in the excellent documentation here. So if you would prefer to read the documentation rather than watch this video tutorial, you're more than welcome to do that as well. So we're going to go ahead and spin up a sample project and actually go ahead and create a really simple basic CSV file, and then we'll just parse that and kind of take a look at how some of these different functions work. But before we get into that, I just wanted to invite you to support this channel. Because I'm an independent content creator, your support goes directly towards helping me to produce new videos on my channel, whether it's Rust or other related topics like database platforms. So please subscribe to the channel. Also check out the pinned comment below where I have a link to my Amazon storefront, which is an affiliate program that helps to fund this channel as well. It helps me to publish free videos for you so that it doesn't have to be a paid subscription service. Also, leave a like on the video and leave a comment down below and let me know what you learned from this video and what other kind of topics you're interested in seeing on my channel. All right, so let's go ahead and jump in and actually create a new project. Now, again, as I mentioned in most of my videos, if you go back to the first video in my Rust tutorial playlist, which is featured right on my channel page, I have a Linux virtual machine set up here that I have VS Code connected to remotely. So I'm using the remote SSH extension for VS Code in order to connect out to that virtual machine. You can certainly develop locally on Windows or Mac OS X as well, but in general, I just prefer to do my development on a Linux VM because I can just rapidly rebuild that with LXD. I've also got a really cool tutorial series on LXD, so feel free to check out those videos and how to use LXD to spin up virtual machines on a Linux server as well. So in here, we're just going to create a new project folder. We'll call it CSV test for now. Then we'll do Control-K, Control-O, and open up that directory inside of our editor here. Also, you will need the Rust Analyzer extension. I've already got that installed in all of my virtual machine environments that I use for Rust development here. So once VS Code is connected, you can always install that extension into the remote environment, and that'll give you auto completion and a lot of linting help and things like that as well. So what we're going to do for starters is just initialize a new project with cargo init right here. And then in cargo.toml, we don't have any dependencies. So of course we need to include the CSV dependency. Over on the crates.io registry here, if you just do a search for CSV, generally this package is going to come up first here, and it is pretty popular. It's got over 35 million, approaching 36 million downloads here, and it is pretty well up to date. There's 79 historical versions, and the author is doing a really great job of just maintaining this library and keeping it up to date. So we're going to be installing this. Also, there's no additional features when we do cargo add CSV. You'll notice that there's no optional features. When we've done videos on things like Tokyo or Smol or other crates, you'll oftentimes see that there's optional features that you can enable, or even serde for that matter. But in the case of CSV here, there are no optional features that you need to worry about. So you don't need to do cargo add and then specify the features parameter to enable those. You get all the functionality of the CSV crate. And then what we'll do is go over into our main.rs file here, get rid of that hello world right there. Let me go into Zen mode here to clean up our screen real estate. And now we can start to plug into the CSV crate. Now, the other thing I'm going to do is just create a sample file here. So let's create a file in our project at the root, because typically I am executing it at the root with cargo run. And I'll just call this data.csv. And you can come up with whatever kind of sample data that you want to. I've found some sample data sets on GitHub that cover things like blood pressure for different genders. There's all sorts of, vehicle data out there. You can even request data from your local government as well through open records requests. So there's lots of different ways to get access to some raw CSV data that represents kind of real world things. But for now, I'm just going to go ahead and create something called manufacturer, model, and VIN. And we'll just use these three individual fields to represent vehicles, right? Common makes and models. So we'll just do maybe a BMW 335i, and say the VIN is 789. We'll do a Chevrolet, or let's do a Nissan Rogue and do 567. And then we'll do a Tesla Model X, and that'll be serial 123. So this is our very advanced CSV file here. We are going to use commas for starters here just to keep things relatively simple, but we'll take a look at how to use that ReaderBuilder type in order to customize the behavior of parsing the CSV as well using different options. So back in main here, the first thing we want to do is call into CSV here and create one of these readers. And so you'll just go into CSV and then grab reader, or you can do a use statement and say, I want to use the reader struct right here. And then we don't need to worry about prefixing it. And then we can go ahead and call from path and specify the path to a file on the local file system. And so let me create a variable called file name, and we'll set that to data.csv. And then I can always shadow that variable or overwrite that variable with a new value if we need to. And so I'll just pass that in to this function right here. And we'll say, let my reader as a variable equal the result. Now, this is going to give you a typical result object here that wraps either the reader with the file as the backing store for the reader. Again, there's lots of different implementations of the read trait in the standard IO namespace, but there's also the error here. So if maybe a file doesn't exist, like maybe if we try to point to data2.csv that doesn't actually exist on the local file system, then we'll probably get an error. So let's go ahead and try to see if we get an error from this. So we'll say if my reader dot is error, then we'll say print line failed to read CSV, file path probably doesn't exist, or you don't have permission. Okay, so let's go ahead and run that. We'll do cargo run. We'll compile our dependencies there. And as you can see, it says failed to read CSV. And that's because we specified a path that doesn't exist, right? So now if we change the file to data.csv, you can see that our program runs just fine. We skip over this if statement here because it's working fine. And the other thing we can do is to just exit out. So I think we can just do standard process and then exit, and we'll just exit with some non-zero exit code directly if there is an error. So that way, any code that we use after the fact is not going to run because we are exiting our process right here. So if an error occurs, we just want to exit immediately. Otherwise, we'll go ahead and write some code as far as what we want to do with the CSV file right after that. So for starters here, we can just say my reader dot records, I think. So let's go ahead and, oh, we actually need to grab the result. So let's do my reader dot unwrap, and I'll say let reader, and I'm actually going to change this to result because that's the result object. And then we'll do result.unwrap and assign that to my reader because that's the actual reader itself. And then we can do my reader dot records, and this is going to grab the iterator across all of the individual records. So typically what you're going to probably want to do is just to do a for loop to iterate over all the records in that list. And so we'll say for record in my records, go ahead and do something. Now we're also getting this error here saying that we cannot mutate immutable variable because we didn't declare the reader as mutable. So let's do mute reader here on line 11 and turn my reader into a mutable variable. And so then what we'll do is inside of our for loop here, we want to do something with the individual fields. So for each record, we're going to iterate over in the data.csv here. We're going to start with record number 1, then we'll go to record number 2, and finally record number 3. And what do we want to do with each of these records? Well, we can reference these individual fields because we know the structure of the CSV file here. We know that the field 0, or the very first field, index 0, is going to be manufacturer, 1 is going to be model, and 2 is going to be VIN because we have a 0-based index. So what we can do is say our manufacturer is, and then insert a placeholder for the manufacturer. So now what we need to do is go to the record that we have right here and actually attempt to retrieve the value of the first field or the first column inside of that record. So the way that we do that is grab the record here, which is wrapped in a result. So we'll do record.unwrap, and then we'll go ahead and call the get function here, which is on the record type. So again, if we go over to the CSV documentation, take a look at the data structures here and go to the record structure. So it's going to be a string record right here. And we have the get function, and this allows us to retrieve a field value at that particular index. So we'll say, I want to get the 0th index here, and that's going to give us an option type. So we actually need to unwrap the final value from that, and that should show us what the car manufacturer is. So now if we do cargo run, you can see that we print out from each record in the CSV file, we just get the manufacturer value. We can also use the other fields in there though. So we could say your car model is X, and then we'll go ahead and grab field number 1, and your car VIN is field number 2, right? So what we're going to go ahead and do is actually take record.unwrap right here and just assign it to a variable, because we're actually using it multiple times, and that's causing a move operation to occur, so we're losing access to that record. So I'm just going to say let car equal record.unwrap, and then we should be able to do car.get on each of these fields here. And yep, that's going to compile just fine. So now we can do cargo run, and we are grabbing the manufacturer model and VIN independently in each of these records here. So as you can see, it's really, really simple to read CSV data. Now, one of the things you might have noticed is that the very first row of our CSV file here didn't get printed out. So it doesn't say your car manufacturer is manufacturer. It just tells us the actual field values here, because it's only looking at rows 2, 3, and 4 and not the very first row. However, some of I just realized I have a little typo there, so we'll call it manufacturer. But it didn't matter because we were indexing by the ID or the index number, not the actual field name. When we go to use serde, though, that's where we'll actually deserialize the file based on the field name instead of the field index. And so it's much more important when we're using serde. But anyways, now that we've got that fixed, you'll notice that this very first row here is not being printed out. And that's because the reader by default is going to assume that there is a header row in the CSV file, and it's going to skip over that header row. Now, if you use the ReaderBuilder, you can actually specify that your reader should not have a header row. And so you can actually force the CSV parser to interpret that very first header row as a data record, just like the remainder of the records in the CSV file. So instead of going directly to the reader struct here and calling from path, we're going to switch over to actually using the ReaderBuilder instead, so that we can apply some advanced customizations to our CSV parser. So what we'll do is import the ReaderBuilder type. So we'll put we'll put curly braces around this because we need to actually grab multiple imports here. So we want reader and ReaderBuilder this time. And now we're going to create a builder before we create the reader itself. So to create the builder, we'll just say let builder equal the ReaderBuilder, and then we'll go ahead and just new it with a new function here. And then we can use the period operator here to take that instance of the ReaderBuilder and call some customization functions on it. For example, if we wanted to specify that there are no double quotes, I think by default it is looking for double quotes, but we can just say, well, I know I don't have double quotes, so just don't bother with that. We could also specify a comment here and take in an option U8. So what we could do is just specify a binary value here of, let's say what's this, our slash. So we're going to say if it starts with a dash here, then we'll go ahead and specify that that's going to be a comment. We could also chain something else and say has headers is false. And so that'll force the reader to include the header row as an actual data row. And there's other helpers in here as well. So we could do something like quoting rules or set the custom quote character if we wanted to. We could even set a custom terminator. So if we want to override the line termination character, instead of using a new line character, we could actually specify that it is something else instead. So a lot of different options depending on what the exact format of your CSV file looks like. So now that we've got this builder, right, we've got this mutable reference to a builder, but now instead of directly instantiating the reader from the reader struct, we want to go to this builder and specify that we want to create a reader using the builder's customized options. So what we'll do is go to the builder. And again, this is all in the documentation, so I just want to show you where you can look this up. So under the data structures in the CSV crate here, we'll go down to the reader builder. And again, we have the from path and from reader. So from path is what we're going to use again, but we're going to call from path on the reader builder, not the reader, right? So what we're going to do is say builder.fromPath and then pass in our file name. And I'll just comment out line number 6 for now. And we'll say let the result equal builder from path. And then we also need to make sure that we unwrap the results there. Actually, we're going to check the error on it, so I'm not going to unwrap it right here. And that'll allow this error handling code to be maintained there. Now, one other thing you can see is temporary value dropped while borrowed. So what we're going to do is just start by instantiating the builder, and then we'll do builder dot, and then we can customize all of these additional values. But we do need to make the builder mutable because we are changing some of the options that are internal to the state of that builder instance right here. So if you get that error saying temporary value dropped while borrowed, then just separate these lines so that you instantiate the reader builder, and then you apply the method chain to customize its options. All right, so let's go ahead and give this a try. So we should include the header row as a data row this time. We should also have a custom comment prefix character, so any lines that have a dash ahead of them should not be included as data rows. And then we also specified that we don't have double quotes, but I don't think that that's going to functionally change anything with our file since we already don't have double quotes anyway. So let's give this a run here. And as you can see, it works pretty much the same as just doing a standard reader with a couple of exceptions. So number one is you can see right here that we have our car manufacturer is manufacturer. Your car model is model. Your car VIN is VIN. And that's again because the very first data row that we have here is being interpreted as a data row rather than a header row. So we're telling the CSV parser that we don't actually have a header row in our file, so therefore use it as, or interpret it as a data row, right? Now, what else did we customize here? Well, we also specified a comment. So if we wanted to omit a certain row, like the Nissan Rogue right here, we should be able to put a dash ahead of that. And now when we run this, you can see that the Nissan Rogue vehicle is completely omitted from the record result that we get back. So down on line number 16, where we call myReader.records, this method call to records is not returning, it's not including the Nissan Rogue row because it was prefixed with a dash, which effectively commented out or ignored that particular data row. So you can use that with any character that you want. You could make it an asterisk if you want. You know, we could change that dash to an asterisk instead, do cargo run, and that effectively works the same way. So it's really up to you what kind of comment character you want to use if you are going to specify one in the Reader Builder configuration. So feel free to check out the documentation for the Reader Builder and look at some of the other helper functions that you have to customize the parser for CSV. All right, so now we've taken a look at the reader type. We also took a look at the reader builder. Let's go ahead and tack on serde. So we're going to include serde as a dependency, which up to this point we haven't done. We've only used the CSV package and any direct dependencies that the CSV package has, or crate, I should say. So if we check out the CSV package on crates.io and take a look at the dependencies here, you can see that CSV core is a dependency, ITOA and REU and serde is actually also a dependency. But right now, serde is actually a transitive dependency because if we take a look at our cargo.toml file here, we don't actually have serde declared as a direct dependency. Instead, it's a transitive dependency because it's a subdependency of a dependency that we explicitly specified within our Rust project file here. So what we want to do is, for starters, do a cargo add serde here, and this is just going to install the default feature. So now CSV didn't have any features that were optional, but serde does. And generally when you're working with serde, I would say probably 95 or maybe even north of 95% of the time, you're going to end up using the derive feature of serde because this allows you to annotate your data structures and individual struct fields to customize the way that serde behaves. Again, if you go back to my video on serde with JSON, we actually covered how some of those attribute declarations work so that you can customize things like field names and convert things like that, convert between different cases like camel case or Pascal case or snake case and things like that. So we're going to go ahead and include serde here. And once we've done that, we also want to add the feature called derive. So we'll do cargo add serde features derive. And now we should see the little blue plus sign next to derive and standard or serde derive. That actually might be green on some other systems, but I think the color theme that I'm using in VS Code here is just making green show up as kind of a light blue color there. So I'm not entirely sure what that should be, but I think it might be green. All right, so now back over in our application here, let's come up with a data structure that actually represents the data rows in our project here. So what we're going to do for starters is just eliminate this has headers thing because we don't care about that. We want to make sure that we include the header row as actual headers. But the double quote thing, we can ignore that. The comment thing, we can ignore that as well because I don't think we have any fields commented out right now. No, we don't. So that should take us back more or less to what the default configuration looks like. So now what we're going to do is come up with the data structure to represent our kind of schema here. So we have manufacturer model VIN. So we'll just do a struct car, or you could do something like vehicle maybe. And then we're going to define the individual fields. So we'll have manufacturer, and Rust prefers that we use snake casing. So we'll say manufacturer is a string type. We'll say model is a string type as well. And VIN, let's do lowercase VIN, is going to be a string type as well. Now, in order for us to be able to deserialize our CSV data rows as the vehicle data structure here, we actually need to annotate this with a derive attribute. So we're going to say derive, and then we're going to use serde and deserialize. We have two different traits here. So if we wanted to write CSV data, we would need to be able to take the data structures in memory and write those or convert them as a CSV interpretation. But for now, we're just reading data in this particular video. So we only need to deserialize or translate the CSV structure into the in-memory representation of a vehicle. So we'll say deserialize and also include debug here in case we want to do debug output of our custom data structure here. And we're getting some warnings saying those are never read. We don't really care about that for now because eventually we are going to read those. But now we need to customize our code a little bit down here because instead of just iterating over the records, we actually need to call the other function on the reader type here, which is called the deserialize function. So let's go back to the CSV root, go down to data structures, go to the reader, because we're still going to have a reader that points to a file. But the only difference is that instead of calling the .records function right here to get the string records iterator, we're going to be calling the deserialize function instead. And this is what references the deserialize owned trait in serde and allows the CSV crate to actually interpret our CSV data rows as individual instances of our custom user-defined data structure. So what we're going to do is just include, as you can see in this example down here, debug and deserialize. You don't really need debug, but we're just going to include that. And then we also can use the serde attribute here in order to rename fields. And this is really important because if you have any differences between these headers and the struct fields that you've defined for your custom data structure, then the interpretation or the deserialization process is going to fail. So right now, if the only thing that we did was change this to .deserialize, and we grabbed a record, you're going to see that it's an unknown type here because we have to annotate exactly what the record is. So in this case, we're going to unwrap the record as a car type. And so it's actually a vehicle type. I forgot I changed it to vehicle. So we're going to interpret the record as a vehicle. And then by reference, the compiler is able to determine that the result here should be wrapping a vehicle and error because we explicitly declared this as a vehicle down here when we unwrap the underlying value from the result. So we don't have to annotate the record up here. We can actually just annotate the car where we unwrap it. And then the Rust compiler knows by inference what that is supposed to be in the result type there. So if that's the only thing that we changed here, let's also clean this up because we don't have any direct references to reader. We're just using the ReaderBuilder to create the reader, so we don't actually have to reference that type. Actually, we do, because now it's saying that we don't have a method down here. Actually, no, that's because we're changing to our data structure. Yeah, so the other thing we need to do down here is once we turn the car from a record, just a generic string record, where we just have the field indices 0, 1, and 2, now we actually want to go grab the field values from the struct instance. So now we can do car.manufacturer. We can also do car.model, and we can do car.vin. But do you think that this example is going to work, right? We're referencing manufacturer model in Vin. We've got deserialize here, but let's try this and see what happens. So let's just do cargo run here. And we should get a panic, I think, in our results. Yeah, sure enough. So our main thread panicked. And the exact reason that this is happening is because it says missing field manufacturer. And I want you to pay really close attention to the casing of that manufacturer field, because on our custom data structure here, we have a more rustic style snake case where we have a lowercase leading character. But if you look at our CSV file, this could have come from some other location, like an external vendor, so we might not have direct control over the schema. And so in this particular case, we have a capital M as the prefix for the field headers. So what we need to do is actually take advantage of the serde features. We can head over to serde.rs where the documentation is for the serde crate. And if we take a look at field attributes here, so this is how we can customize the behavior of individual struct fields during the deserialization process. And what we can do is tack on the serde attribute here and specify that we want to rename the field as something else. So we can rename the capital manufacturer as a lowercase manufacturer instead. And so what we're going to do is just add this on, and that'll allow us to successfully read the file. So let's go ahead and add the serde attribute here. And you can see that we actually have the ability to serialize and deserialize as different field names. So if we wanted to convert this file from using capitals to lowercase, we could actually say, I want you to deserialize it as a capital M manufacturer, but I want you to reserialize it using a lowercase m manufacturer that's more consistent with our Rust code. So it's really up to you what route you want to go with that, but we'll just say rename and then deserialize and set that to manufacturer. And then I'll just do Alt-Shift down arrow to duplicate that line a second time, and we'll just use that same syntax here for model, and we'll also customize Vin, which is all in capital letters right there. All right, so now that we have specified to the serde library what our deserialization field names should be, let's go ahead and try this again. We'll do a cargo run, and as you can see, everything looks perfect here. We're reading the individual data rows. We're not including the header row because we commented out the has headers there, but everything else is working fine. Now, if we had a CSV file that was a little bit different, let's say that maybe we replace, let's do a Control H here and replace commas with pipe characters. Then we'll do Control Alt Enter in VS Code to just do a replace all in this file. So now this is probably going to fail again, because we no longer have a valid CSV file, right? By default, the CSV package or crate is looking for a comma separator, but right up here, again, because we're trying to deserialize with serde, it's saying it can't find a manufacturer field at all. So what we're going to do is just customize our reader builder once again. If we head over to the docs for that reader builder type, in the CSV docs here over at docs.rs, you can see that we've got a delimiter here. And the delimiter just allows us to specify a byte value that indicates the character we want to use as the field delimiter. So in this example right down here, they overrode the delimiter to a semicolon, but we're going to be using the pipe character instead. So back over in our code right here, we're just going to go up to the line where we create the builder, and we'll tack on another method to our method chain, specify our delimiter as a binary, let's say, or a bytes value, I should say, which is going to be a pipe character. Go ahead and save that, do a cargo run, and once again, our file is being interpreted correctly. So as you can see, there's a bunch of customization options that we have here. We have the option to use serde to do the deserialization if we want to into a custom user-defined data structure, or we can just use that get function on the individual records to grab the fields or columns from those CSV data rows by using the field index number instead of the field name. Personally, I like the deserialization mechanism because it does allow me to make my code a lot more readable, where I can actually specify what the field name is on the actual data structure. And as you can see, we also got the auto completion here because Rust knows that we're dealing with a vehicle type here, so we can auto complete those field names directly here in our code. So I prefer that approach, but it does require just a little bit more coding here in order to implement those custom data structures. And if the input format of your CSV ever changes, then you'll want to make sure that you come update your data structure and deserialize any additional fields that are provided in your source data. So that's pretty much everything I had for this video. Again, thank you so much for watching. I hope that you learned something new. Again, please support the channel by liking, commenting, subscribing, and finally going to my Amazon storefront and just purchase some common household items through there. I've got a whole bunch of different things that you can purchase through that Amazon storefront. It's in the pinned comment or the description down below. Thanks so much for your support, and we'll see you in the next video. Take care.